Here once again is a marvel of engineering before you. In 1847, Bishop Rock, a barren granite outcrop 4 miles west of the Scilly Isles, sent yet another ship into the cold waters. The reefs barely remained above the surface at high tide, disappeared entirely during storms, and lay directly in the path of vessels rounding Land's End. The authorities of Trinity House, Britain's lighthouse authority, decided that the rock needed a warning light in order to ensure maritime safety. However, Bishop Rock offered them no shelter, no soil, and no fresh water. Atlantic waves never ceased, striking the exposed granite at heights exceeding 100 feet and with pressures measured in tons per square foot. As a result, engineers proposed what first seemed the most logical solution: an iron framework lighthouse, light, flexible, and able to withstand wave impacts through movement rather than mass. Construction was completed in 1850, but the first major storm completely destroyed the structure. Today, more than 140 years after the replacement tower was completed in 1887, this granite lighthouse still stands on Bishop Rock, still operational and still enduring everything the Atlantic can deliver. The flexible iron tower has long passed into history, but the immovable granite masterpiece continues to exist. You already know there is a subscribe button beneath this video. By making this small gesture, you can support our channel. Do not see it as just a subscription. Through it, you will also learn what people endured while creating extraordinary works in the past. So please like the video and subscribe to the channel. The original tower, built in 1850, was designed by Trinity House engineer James Walker. Walker proposed an open iron framework structure, 120 feet tall. Cast iron legs would be anchored to the rock with wrought iron bolts, and a lantern room housing the light would sit at the top. In theory, the idea looked very strong, allowing waves to pass through the framework rather than strike a solid mass. Storm waves would dissipate their energy between the legs. The structure would flex and return to its original form. The design had previously been seen to succeed on other exposed rocks, and he believed Bishop Rock would be no different. Construction progressed under terrible conditions. Workers could land only during calm weather, which occurred perhaps 20 days each year. The rock surface was sloped and offered very little flat area for joining structural materials together. Holes were drilled by hand into the granite for the foundation bolts. Each cast iron leg weighed several tons and had to be positioned precisely. Work advanced in short intervals between Atlantic storms. The lighthouse took 3 years to build. When it was completed in February 1850, Trinity House was preparing to install the lighting apparatus and commission the station. Before that could happen, a winter storm struck in February 1850. Waves exceeding 80 feet battered Bishop Rock. When the storm subsided, the iron tower was gone. Exactly as Walker had feared, every leg of the tower had been torn from its bolts. Pieces of cast iron were scattered across the reef. The structure that was meant to flex had been completely destroyed. No one had been inside. The tower had never been occupied, and failure had become inevitable. The force of the waves had exceeded every calculation. The rock was considered too exposed for any lighthouse. Trinity House reconsidered. Ships continued to wreck on Bishop Rock. Lives continued to be lost. It was clear that without a light, loss of life could not be prevented. In 1851, Trinity House appointed James Douglas as the new engineer. Douglas had previously assisted his father on lighthouse projects and knew exposed rock construction well. He studied the failed iron tower and reached a different conclusion. His answer surprised everyone, because the solution was not flexibility, but mass. If waves could destroy an iron framework, then granite would replace it. The new lighthouse would be a massive stone tower, immovable, designed to absorb every wave the Atlantic could produce. Douglas designed a circular tower, 92 feet tall, tapering from a 40-foot diameter base to 16 feet at the top. The walls would consist of granite blocks dovetailed together in each course and bonded vertically with stone dowels and Portland cement. Mortar joints would not be exposed to wave action. Each block would lock into its neighbors, forming a monolithic structure. The first 30 feet would be solid granite. Living quarters and the light room would be above. The entire tower would weigh over 5,000 tons. Waves striking it would meet an immovable object. And then the moment had come. Construction began in 1852 and lasted 6 years under conditions that made the original tower seem simple by comparison. The solid stone design required the cutting and shaping of thousands of granite blocks, each weighing between 1 and 3 tons. The blocks were quarried in Cornwall, shaped to exact specifications, numbered, and transported by ship to Bishop Rock. Landing them on the sloping, wave-washed rock required precise timing and considerable risk. Workers could operate only during calm seas and low tide. Progress was measured not by weeks, but by the number of blocks placed per month. Foundation preparation was brutal work. The existing rock surface was irregular and sloped. Douglas ordered it leveled and shaped to create a circular platform for the tower base. Workers drilled, chiseled, and blasted the granite by hand, creating a foundation bed 60 feet in diameter. Seawater constantly washed over the work area. Men wore oilskins and worked in teams. While one group chiseled, another waited to take over when the first was exhausted. Injuries were common. Some workers were swept from the rock and drowned. Yet construction of the lighthouse continued without pause. Once the foundation was prepared, stone laying began. Each course of blocks was positioned, checked for level and alignment, and secured with stone dowels driven through pre-drilled holes. The best materials were used, applied only in the dowel holes and narrow joints hidden from wave impact. The blocks were locked together with dovetail joints, visible only from above. As the tower rose, wooden scaffolding was erected inside to support the vaulted ceilings of the living quarters. Everything was designed for rapid assembly during brief weather windows and absolute durability once in place. The lowest 30 feet of the tower were solid granite, with no door, no windows, and no openings of any kind. The entrance was positioned 30 feet above high water, accessible only by ladder in calm conditions. This meant lighthouse keepers would live completely cut off from the world, except for rare supply boat visits. The living quarters were cramped. 3 circular rooms stacked vertically, each only 14 feet in diameter. The keepers would spend months isolated on the rock, maintaining the light through storms that shook the entire structure. The job required men willing to endure conditions most people would consider unbearable. At the top, the lantern room was fitted with a first-order Fresnel lens, the most powerful system available, capable of projecting light 20 miles in clear conditions. The lens and mechanism were housed within a bronze and glass structure designed to withstand the highest waves. Storm waves sometimes struck the lantern room 92 feet above the rock, smashing glass panes and flooding the mechanism. When the light failed, the keepers had to repair the damage during brief lulls between waves, working in near-total darkness. If injured, there was no rescue. If they became ill, there was no medical aid. The light had to be maintained regardless. The great day had arrived. Construction of the lighthouse was completed in September 1858, and the first keepers moved in. It was even Douglas himself who lit the first lamp. Bishop Rock finally had its warning light. For the next 129 years, the tower operated with keepers permanently stationed on the rock. They lived in isolation, broken only by fortnightly supply boat visits during calm weather. In winter, they could be cut off from the outside world for weeks. They kept detailed logs of wave impacts, weather conditions, and maintenance work. These records documented wave heights exceeding 100 feet during the most severe Atlantic storms. The tower proved its strength immediately. The first winter brought numerous storms that would have destroyed a lesser structure. The granite absorbed impacts measured in tons per square foot. The tower vibrated but did not move. The dovetailed joints held firm. The stone dowels remained locked. Waves that had destroyed the iron tower 9 years earlier now simply washed over the granite and lost their energy. The difference was fundamental. The iron tower tried to survive through flexibility. The granite tower survived through absolute immobility. But then, something unexpected happened. Douglas had designed for known wave forces. In 1881, a storm generated wave impacts beyond anything previously recorded, and waves exceeding 120 feet struck the tower repeatedly. Vibrations shook equipment from shelves inside. The keepers feared the structure would collapse, but it did not. However, inspections afterwards revealed cracks in some granite blocks. The stone remained sound, but the forces had approached the tower's design limits. Trinity House officials faced a decision: accept the cracks and continue operating, or strengthen the tower beyond what any engineer had considered necessary. Of course, they chose to strengthen it. In 1883, James Douglas's son, William Douglas, was appointed to redesign the tower, but his solution was a severe one. Encase the existing granite tower within an outer cylinder of new granite blocks, increasing the diameter and adding massive weight. The new base would be 52 feet in diameter, 12 feet wider than the original. The height would rise to 146 feet. The additional granite would add more than 2,000 tons of weight. The lighthouse would become a granite monolith, weighing over 7,000 tons, anchored to bare rock by its own mass and interlocking stone. The reconstruction took 4 years and was even more difficult than the original construction. Workers had to build around the existing tower while it remained operational. While keepers continued tending the light, masons laid new granite blocks encasing the structure they lived within. The logistics were extraordinary. Every block had to be shaped precisely, transported to the rock, and positioned without damaging the original tower. Work could proceed only during calm weather. The project cost more than £35,000, nearly 3 times the original tower. Critics called it extravagant. Trinity House called it necessary. The light could not fail. The reconstructed lighthouse was completed in 1887. The new tower overshadowed the original. The base now covered most of the exposed rock. The increased diameter and height created a structure that dominated the surroundings and the reef. The added mass changed the tower's response to wave impacts. Whereas the 1858 tower had vibrated under severe strikes, the 1887 tower showed almost no movement at all. The granite mass was so great that waves could not shift it. The tower had truly become immovable. The following 140 years have confirmed that decision. Bishop Rock Lighthouse has survived every Atlantic storm since 1887. Waves continue to strike the tower during winter gales. Sea spray continues to reach the lantern room 146 feet above the rock. Yet the granite shows very little wear. The dovetailed blocks remain locked together. The stone dowels have not shifted. The tower inspected in 2024 is structurally identical to the one completed in 1887. The keepers were withdrawn in 1992 when the light was automated, but the structure they maintained for over a century remains exactly as they left it. The contrast with modern lighthouse construction is striking. Today's navigation lights are generally built as steel or concrete platforms designed for service lives of around 30 years. They require regular maintenance, frequent repainting, and eventual replacement. Bishop Rock Lighthouse, however, was designed for indefinite survival. It requires very little maintenance beyond occasional repointing of mortar in areas above the wave zone. The granite blocks themselves show no deterioration. A structure built 137 years ago functions as well today as when it was new. The engineering philosophy that led Douglas to encase an already strong tower in additional granite has been validated by more than a century of Atlantic storms. This lesson extends beyond lighthouses. The same logic that produced 7,000-ton granite towers on exposed rocks also produced 4-foot-thick mill walls, 3-foot sewer tunnels, and 6-foot coastal fort walls. Victorian engineers consistently overbuilt because they understood that structures in extreme environments could not easily be replaced. Bishop Rock Lighthouse is the perfect example of this philosophy. A structure designed to withstand forces that could not be accurately predicted, built from materials known to last centuries, and engineered with safety margins far beyond any calculation. James Douglas died in William Douglas died in 1923. Neither lived to see their lighthouse survive 2 world wars, the decline of maritime traffic, and the automation that ended permanent human occupation. But they built knowing the tower had to outlast shipping patterns, technological changes, and the economic forces that made lighthouse keeping obsolete. The light still guides vessels past Bishop Rock. The tower still stands exactly as William Douglas completed it. The waves still strike. The granite still endures. Today, when you walk the cliffs of Cornwall and look west towards the Scilly Isles, on clear days, Bishop Rock Lighthouse can be seen as a white tower rising from the Atlantic. It stands alone on its reef, 4 miles from land, exposed to the full power of ocean storms. No other structure occupies that position. No modern engineer would propose building there. The cost would be rejected, the design called excessive, and the entire concept deemed unnecessary in an age of GPS and electronic navigation. Yet the tower stands, a monument to engineering that refused to accept good enough when lives depended on absolute reliability. Critics called the 1887 reconstruction wasteful. Time calls it wisdom. The Atlantic calls it immovable.